In this video, we'll be obtaining LR0 items for the given grammar and check if the grammar is SLR or not. So here there are three productions: S derives SA, S derives A, and A derives small a. So I'll consider these three productions and name this as grammar G. So before proceeding to find the LR0 items, we should find first and follow of the non-terminals here. So that is S and A. Writing the first and follow of S and A. First and follow. So first of S would be small a, and first of small a would also be small, capital A would also be small a itself. And follow of S, I'll have dollar here, and I'll have small a here. Here also dollar and small a. If you have to understand how I obtained first and follow, do refer my previous videos. I have explained stepwise how to obtain the first and follow along with the algorithm. So once we have obtained first and follow, let's move on to the next step, that is to obtain the argumented grammar G dash from the given grammar G. So in order to obtain the argumented grammar, I need to remember certain rules. That is, if the production if S is the start symbol, then I can write, then I have to start by writing S dash derives dot S, and I have to reduce this to the form S dash derives S dot. So after dot, if there's a non-terminal, suppose X is there, and if X is a non-terminal, then I should write all the possible productions of X need to be written with prefix as dot. So if it's of the form A derives X dot X, so I should convert it from A derives dot X to the form A derives X dot. So my aim is to shift the dot from starting to the end. So let's start writing the argumented grammar. First I'll start with S dash derives dot S. Here S is the start symbol, so it would be S dash derives dot S, and after dot I have a non-terminal, that is S, so I need to write all the possible productions of S with prefix as dot. So I'll write S derives dot SA, S derives dot A, and here S is there. I have written the expansions or the productions of S, so you need not consider this. Here I have A being a non-terminal, write all the possible productions of A with dot as its prefix. So I have obtained this. I'll write down these items in a table and name it as I0. So I0 I have obtained. Next, my aim is to shift this dot to the end in each production, right? So over S, I can shift this dot over S. So I'll write S here. So I'll get S dash derives S dot. So this is done. And this production, this dot could also be shifted with over S, right? So I'll write S derives S dot A. S derives S dot A. A being a non-terminal, I should write all the possible productions of A with dot as its prefix. So A derives dot A. So here I have written down I'll write it as I1. I'll name these productions as I1, that is item 1. So I'm done with these two. Now I have capital A here, so I'll write S derives A dot. So I'll name this as I2 production, and here I3 would be over small a. I get A derives A dot. So this is I3. Now coming on to I1, Here this is fine, dot is at the end. Here I have to shift the dot over A, right? So I'll write S derives SA dot. S derives SA dot. So I've shifted the dot towards the end. This would be I4 production, and over small a I would obtain I3, right? So here I have shifted all the possible productions, shifted the dots of all the possible productions from the starting to the end. So if you can check it, I4, I2, I3 and I1, the dots are being shifted. Now I am done with the second step. My third step is to compute the SLR parsing table. So here I have constructed the parsing table with the items on this side and action and go to part. Action part would comprise of the terminals and go to part would comprise of the non-terminals. So starting with I naught. So here I need to check that. So starting with I naught, I need to check if I have a terminal, then I should perform the shift operation, and if I have a non-terminal, then I should perform the go to operation. So remembering this, I naught over S, S being a non-terminal, I will get I1. So I naught over S, I would get 1 here, and I naught over A, I would get 2 here, and I naught over small a, I would get I3. So here I will write shift of S3. So I am done with I naught. Now moving on to I1. So here I need to remember, if I have any production of the form S dash derives S dot, where S is the start symbol, then I can write I of I, that is that particular item number, comma dollar, should be filled with accept. That is, here I have S dash derives S dot. This being S being the start symbol, I should write in I of I. Here I of 1, comma dollar, I should fill accept. So in I1 comma dollar, I should fill accept. So I'm done with I1 on A. I1 on capital A, I get SI4. I1 on capital A, I should write 4 here. Sorry, 4 here. I1 on small a is I3. That is S3. Okay. So I'm done with I0 and I1. I2, nothing, I can't write it further. I3 also I can't write it further. I4 also I can't write it further. Now I should look into the reduce part. So if I have any production of the form A derives alpha dot, if I have any production of the form A derives alpha dot, then in action part I can write that particular line number, comma, follow of A should be equal to reduce of A derives alpha, this particular production number from the given grammar G. So I'll explain this considering the examples. Here one more condition is that A should not be equal to S or S dash, that is the start symbol. So if you look at in the I naught items, is there any production of A derives alpha dot form? No, it's not there. In I1 we have S dash derives S dot, but A should not be S here. So S being the start symbol, you can't apply this rule on this particular production. So moving on to I2, here let me write I2. Over I2 I have S derives A dot. So in that case, I of I. So I'll write 2 I2 comma follow of A. Follow of S is dollar $A. is equal to reduce of S derives A is the second production, right? S derives A is the second production, so it will be R2 here. So next, moving on to I3, I have A derives small a dot. So here it would be I3, comma, follow of A. Follow of A, I have dollar and A is equal to A derives small a. A derives small a is the third production, right? So I'll write R3 here. Next, I have I4 here. So writing for I4, that is S derives SA dot. So first write I4 here, and follow of S. Follow of S, I have dollar and A is equal to S derives SA. S derives SA is the first production, so write R1 here. So now that I have obtained the reduced parts, let's fill it in the table. So 2 comma dollar and A, I should fill R2. 2 comma dollar and A, I should fill R2. And here 3 comma dollar and A, I should fill R3. And 4 comma dollar A, I should fill R1. Okay, I have filled all the possible actions and shift and reduce part. So if you look at the table, there are no multiple entries or conflicts occurring in each cell. In that case, I can say that the given grammar G is said to be SLR. So I hope you have understood how to compute the LR0 items and check if the grammar is SLR or not by constructing the SLR parsing table. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.